Hi, welcome to question 8 of the 2023 Junior Cert Higher Level Maths exam. This question is around like measurement, geometry, trigonometry. And part A, which is a 5 mark, is pretty handy. It says convert 7.5 kilometers. Okay, kilometer there is a clue, 2 meters. And then it gives you a box to fit it in. So if we remember that like 1 kilometer is equal to 1,000 meters. Okay, that's the conversion factor. Okay, kilo means 1,000. So kilogram is 1,000 grams. That's the metric system, the core of it. So if 1 kilogram is equal to that, well then, like if I wanted to test this, like 2 kilometers would be equal to what? Now, if I want to convert one into two, I can multiply it by two. Now, as long as I'm consistent in my like algebra, if I do something to one side, I have to do the same thing to the other. So what is the answer? 1,000 times 2 is equal to 2,000. Now, the only reason I'm doing that is I know that answer. So the same logic would apply. So if 1 kilometer is equal to 1,000 meters, if I multiply both sides by 7.5, I end up with my answer, which is 7.5 kilometers is equal to 7,500 meters. Now, for some, that'd be a really easy question to just write it down, no work. Okay, but just be careful because even though this is particularly on the easier side, um, sometimes there's tricks built in, especially at junior or higher level. Okay, so that's the answer. Now, part B then is a 5 marker as well. A lot of words here, so let's go at it nice and slow. Now, usually all the words are reflected in the diagram, but not always. So it's important to read it and read it more than once. My mistake is I read things too fast, read it once and don't really pay attention, just kind of think I understand what's happened. And sometimes I catch that I've, at the end after doing 5 minutes of work, and it's ultimately self-defeating. So a plane P, okay, so that's what they're talking about here, took off from an airport. It left the ground from the point T. So bog standard plane takeoff. After a few minutes, it was 7.5 kilometers from T. So that line there, it's gone 7.5 kilometers, 7,500 meters. And maybe if I wanted to try get an attempt, I'd do that because there is maybe a conversion. And it was 200 meters directly above the ground. Okay, so that's this number over here. They say they show the diagram and it's not to scale. So don't make assumptions of the diagram based on how it looks to your eye, especially even on these notes that could be stretched. It says use trigonometry to work out the size of the angle marked E in the diagram and then give your answer in degrees, correct to 1 decimal place. Okay. So in essence, if I look at this diagram, what shape is it creating? It's creating a right angle triangle. Now, the second I see it's right angled, my brain starts going, is it Pythagoras? Okay. Or is it the sine cos rule? So sine of an angle is equal to opposite over hypotenuse. Cos of an angle is equal to adjacent over hypotenuse. Tan of an angle is equal to opposite over adjacent. So I'm looking for an angle. Okay, so it's probably not Pythagoras. Okay, now I could use Pythagoras and I could find this side down on the bottom. How far, that's not what's being asked, so it's irrelevant. And then I have to decide which of these three formulas will work. And there's three separate formulas. But to do that, I need to know what the opposite and the hypotenuse are and the adjacent. So the hypotenuse is always the side across from the biggest angle, which by definition in a right angle triangle has to be the 90 degree. So this is the hypotenuse. The opposite is always one of the trickier. The opposite side is opposite to the angle you're looking for. So in this case, the side opposite E is the 200, and the other one is the adjacent. This is the way I personally remember it. Okay. So we have all three sides. Now I'm going to see, can I use sine? Actually, I can. I'm looking for the angle. Okay. I have the opposite and I have the hypotenuse. So there's three unknowns in that particular formula, in all of those formulas. If I know two of the three things, I can find the other thing. Now, sometimes I don't want to find the other thing, but another formula may work. But I'm looking for the angle. That's what's missing. So this will work. I'll just jump across to the answer. So that's the formula. Now I've decided to go in kilometers for some reason. Okay. So I've done a conversion here. 200 meters in kilometers is the same. To do that conversion, you divide by 1,000. Okay. And that gives me an answer of 0.2 kilometers. I could have gone meters. I don't see why I didn't. And done 200 divided by 7,500, which is the same number. Okay. What I'm saying there is 200 divided by 7,500. This number and this number are the same number. They just don't necessarily look like it. So ultimately, all the sine, cos, tan rules are what many other people have written down through measurement of the angles created in a right angle triangle. It doesn't matter if a triangle is like this small or this small. If the angles are the same, okay, the ratios are all the same. And we just noticed that and they wrote it down. So if we know a little bit about a triangle, we can find out a little bit more using trigonometry. And eventually, in most cases, we can find out everything. And that's very useful in many, many, many different ways. Okay. So if I keep going, so that's my number. Now I can convert that to a number in the calculator. It might be a big long decimal, so I'm better off leaving it like that. And then if I bring sine across, in essence, so sine of an angle is equal to this number. So the angle is equal to the inverse sine. So if you bring something over to the far side, it always changes into its opposite. The opposite of sine is inverse sine. And it's inverse sine of everything on the far side, which is a pure calculator job. Okay. Now, when I put that through the calculator, I'm making sure my calculator is set to degrees, which most modern calculators are. I got an answer of 1.528 degrees. Now, the question says round that to one decimal place. So the number that matters for one decimal place is the 2. 2 is less than 4, so the 5 stays the same. So it's 1.5 degrees. Now, that's probably worth having a think about. Okay, is that a very small number? In fact, I'm doubting it myself, and I'm going to go check the marking scheme. Now, I said no harm showing the marking scheme. So in the marking scheme, you can see there that they actually use the meters, 200 over 7,500. Got the exact same answer. It just, in a way, it seems too small. I think 50, it's just my imagination. It just seems like it doesn't pass what I call the BS test. Okay, like, oh, does your answer, does the number seem to make sense? If it does, fair enough. If it doesn't, just have a second think, which is what I'm doing myself right now. Although while I have the marking scheme here, it's always worth knowing that these are on examinations.ie and they give you the answers. They also give you a hint of how these things are marked. And students who are maybe going for, like, maybe in the Leaving Cert 600 points, they arguably would know the marking schemes better than maybe the teacher. Okay. I probably won't win any prizes for saying that. So trying to get back to where we were. Still recording. Okay, so that's the answer. Now, the next one there, part C, part 1 and 2 here are marked together. It's a 15D, okay, which is a massive chunk of marks. Usually with these, if you get one part fully correct, you get the high partial. It says write 20 minutes as a fraction of an hour. Now, to my mind, this is a ridiculously easy question, okay, but I'll state it. 1 hour is equal to 60 minutes. Remember a few years ago, there was a question in Leaving Cert, but about basically you had to use the number of weeks in a year, and a surprising number of students said 48 weeks in a year. And I assume what they did was just went 12 months, there's 4 weeks in a month, 4 12s is 48, and that's why they used it. But we hopefully know that there are 52 weeks in a year. Not every month has the same number of days, has 28 days. So it just, in the moment, they probably just went with it. But in the reality of it, it's just not a correct statement. So as long as you remember, there's 1 hour has 60 minutes. That's the same thing as 20 over 60 of an hour. Now they say give your answer in the simplest form. The calculator will do it for you. But if I look for a number that will divide evenly into top and bottom, like I could go with 10. 20 divided by 10 is 2. 60 divided by 10 is 6, but that's not simple. If I look again, another number will divide evenly into top and bottom. 2 into 2 goes once, 2 into 6 goes 3 times. Okay, so it's 1/3 of an hour. That's it. So it's actually a very handy part in the scheme of things. But then sometimes when they're this easy, you can just go, wow, that's so easy, and jump on. Okay, so during part of its flight, plane P traveled 598 kilometers in 2 hours. So the distance was 598 kilometers, and the time was 2 hours, 20 minutes. 2 hours, 20 minutes. Now that's 2 hours, 20 over 60, which is the same thing as 2 1/3 hours. Yeah, we'll just leave it. It's all, I'm saying the same thing over and over again. Now work out the average speed of the plane during that time in kilometers per hour. So there's the speed is equal to distance over time. Now that's the triangle. Okay, speed, distance, time is one way of remembering it. And then if you just use units, the distance there in kilometers and hours is going to end up with the right units. So the distance was 598. Now the time was 2 1/3 hours. Okay, so that looks weird, but in the calculator you can do that. Okay, now my calculator should be open. Okay, so we stretch it open bigger. I'm trying to use a touchscreen thing, and it's not working as well as I'd like it to. Hopefully that's visible on your screen. So if I make a fraction, 598 on top, now I can make a fraction within the fraction, and that's where or actually I could even do this. Don't normally do this. 2 and what was it, 1/3. 1/3. Okay, so I'm literally programming the calculator to look just like what's on the page. Press equal, calculator do its magic. Now it wants that to decimal places, so I can always do that. Of course, I didn't remember the number. 1794 over 7. 1794 over 7. But that's not the way they want it, so I'm going to change that to decimal. 256.28. 256.28. 256.28. Now they want it to one decimal place, so the 8 here is what matters. That's greater than 5. The number before it will go up by 1. So it's 256.3 kilometers per hour. So the trick there was realizing that it was the speed, distance, time formula. Okay. And once you were being consistent then in the units, which they didn't do any tricks, sometimes they might give it to you in like the number in meters, and you have to do a conversion, which adds an extra layer. Between part 1 and 2, that wasn't the worst question in the world, especially for 15 marks. So that's the answer there. We've got the same thing. Now this is a bit more challenging, this question here. Part D is only given 5 marks, which would be an indication of the marking scheme that year. This will involve more effort than the previous 2 parts, which were worth 15 marks. So part D says, in the diagram below, each of the points A, B, and C represents an airport. So you have an airport here, an airport here, and an airport here. And you must have planes flying between them. The plane traveled 598 kilometers from A to B, and then on from A to C, which we don't know that distance. Work out the distance AC, corrected nearest kilometer. Okay, so we kind of have information, but we're looking for this length here. It's not as straightforward as we might like it to be. Okay, so I'll clear off all the ink there. But we do know a lot more about this particular triangle over here, which is actually a right angle triangle. Okay, so if I drew that out, I'm partially problem solving here. This is 35, this is 280. If I was to be able to find this side here, corresponds to this side here, okay, that should be of help. Now I've just realized that actually it's this side here is what I am looking for because I'm looking for the length of AC. Okay. So I'm trying to find this little bit here using this triangle here. And then I'm going to try find the other part of it using the other triangle. So I've made an absolute mess now. I'm going to erase everything. I'm just going to focus in on that triangle. Okay, again. So it's side 280, angle 35, it's right angled. Now Pythagoras won't help me here because I only have one of the sides. Okay, but the sine, cos, tan rules, okay, are going to be potentially useful. So this is my angle. So my A is 35. Now my opposite there is 280. Okay, so the side opposite the angle is 280. My hypotenuse I don't have, okay, and my adjacent is the other side. The adjacent is what I'm trying to find. So that's my question mark. So my formula needs to mention the adjacent, and I need to know two of the three things. So sine won't work. I do have the angle. I do have the opposite, but I'd find the hypotenuse, which I could do and then use Pythagoras. Fair enough. But that'd be extra work. Cos I have the angle, I don't have the adjacent, which is what I'm looking for, and I don't have the hypotenuse. So this will not work. I only know one of the three things, so it's gone. Now tan seems to be my best bet. Tan of an angle is equal to the opposite over the adjacent. Now the angle we said there was 35 is equal to the opposite is 280 divided by the adjacent is, it's going to call it x. Now, from a mathematical perspective, this is kind of awkward. I don't want the x to be on the bottom. I want the x to be on top. So if I want to get rid of the x on the bottom, like I could just move it across, cross multiply. But what I have kind of moved over to is the more direct, logical way that algebra works. If I can create a situation where there's an x on top, then anything on top and bottom will always cancel. So if I multiply the top there by x, like, that'll create the situation. And I can do whatever I want in algebra, just it's not always useful. So I can do that. And I'm okay to do it as long as I multiply the other side by x and everything on the other side. Now what's going to happen there is that I'm going to end up with x times tan 35. You could represent that as x tan 35 or leave it the way it is. Okay. But on the far side, the x on top and the x on bottom have cancelled. Now they've become 1, okay, and anything by 1 is itself, so ultimately it's 280. Now then I look at it again and go, look, yeah, it's a little bit simpler, but I still have the x and the tan 35 linked together. So how do I fix that? I want to try use the same colors, but I'm color blind / color stupid. If I want to get rid of this tan 35, the simplest way to get rid of it is to divide it by itself. Okay, that's not the same color. If I do it on one side, I have to do it the exact same thing to everything on the far side. Now, the reason I'm doing that is to create this situation. Okay, anything divided by itself will always cancel. You're left with x. Now, on the far side, 280 divided by tan 35. I can put that into the calculator, just making sure my calculator is set to degrees. Okay, I got 399.88. 399.88. So I found this distance here, 399.88. I don't know why I'm using a new calculator or a new tablet thing. So that's my answer for that little section. Now on the other side, okay, I have to worry about, let me try to get rid of all this, finding the side that's left there. So let's get rid of all this as fast as I can. Probably should have paused it. Okay, so good to go. So I'm going to draw out that shape. Now, I have the magic of an eraser. There is always the extra paper if you do run into a problem. So this is right angled. So again, it's either Pythagoras or the sine cos tan rules. But I'm looking for this side here. It's a right angle triangle. I know the hypotenuse. I know one of the other sides, so I can use that to find the missing side. Now, this is a bit more awkward in the sense that the 598, normally you're looking for the hypotenuse. That's the kind of bog standard thing. I was going to make that big plus and b squared. So in this situation, I want to find what b is. Okay, I've put the hypotenuse in. I've put in one of the other sides. So I want b to stay where it is, and I want the 280 squared to move across. Now, like we did a few seconds ago, I could take away 280 squared. Even though it's an awkward number, it's a big number. I can always take it away from the right hand side. That'll get rid of it. And I'm okay to do that as long as I do the exact same thing on the other side. Okay. So on the other side, no, I think I've got the wrong color. That will be, if I rewrite it, okay, it would look like that. And on the right hand side, they've cancelled out and you're left with b squared. So that's algebra. Okay, it's the same rules over and over again, and it's boring and all that kind of stuff, and I appreciate that. But if you're applying them consistently, you can take away that. Even if it's a bit more long-winded than moving stuff across, you're less error prone, okay, and therefore more successful. Now, that number, I can convert that to like a number, just put it through the calculator if I want, but I can also leave it the way it is. My last step here is I want to get rid of this square. Okay, now the one way to get rid of anything is to do the opposite to it. So if I want to get rid of a square, I can square root the whole thing. Now I'm allowed to do that as long as I square root everything on the far side. And that's where you end up with the big long calculation, which can go to the calculator. And I end up with b is equal to, now I have this done on the next page. If I can flick it. So you see that calculation here, I ended up with 528.397. Okay, and the first calculation was 399.88. If I add them together, okay, I end up with the 928.279 kilometers, and that should be the answer. Okay, so this is a tricky enough question. There's multiple layers to it. It's a good problem-solving question, and often the trick with problem-solving is find something. Even if it's not necessarily useful, you've found something potentially relevant, and that'll get you the attempts. Now, in saying that, this question was only worth 5 marks, which is, in a way, horridly under rewarded for the amount of work involved. And once you break the shape into smaller pieces, find out a little bit you can. Even if it's not useful, it should get attempts. If it is useful, it might help you to find the next thing and the next thing. And then eventually you found everything, and that's it. Your job's done. Okay. Oh, that's the end of question 8. I thought there was another part. So as always, if you want to copy the notes I'm working off, just send me an email at shanetroy@gmail.com. Like and subscribe to get access to more playlists. I'll see you on question 9.